Okay, so now we still in the ammeter voltmeter method, but now we're gonna move to the circuit B, which is a reverse characteristics, right? But obviously from this configuration you can tell this is still forward, right? Because with this connection it's not going to be a reverse, right? In order to get a reverse and to get negative values for voltage, well, in nature there's nothing called negative value for voltage. The negative is an indication for the direction, right? So we're going to do here, I'm just going to flip the connection of the power supply. So instead of the negative parts connected to the cathode, so the positive part of the power source gonna connect it to the cathode. So we're just gonna flip it, and this is especially for the TAs. The other TAs, just make sure to flip the polarity of the voltage supply, and the positive will be connected to this part, to the cathode of the diode. This is very important, and the value of the resistor will be changed from 100 ohm to be 560k, which is, we got to be careful here. So when we do our calculation, it's not going to be just by 560, we're going to be 560,000, right? So in this case we need to form a table of 4 columns: VS, VR, ID, and VD. VS, this is what we are changing here. VR, this is what we are measuring. As you can see here, is the voltmeter is connected across the 560 k ohm. Okay, so the others will be calculated, ID and VD. Well, obviously we talk about it, we're going to use the voltage Kirchhoff law, and we can get these values. So let's start with the increment will be 5 volt. So let's start changing the voltage here to 5 and start getting the first reading. So we will have very much let's say 0.2 millivolt here, very much. So how we can get the first value here? So okay, so let me check this. So I have 0.2 millivolt, right? Times, it's a millivolt, you gotta be careful. So I have that much of voltage across the resistor, right? So in order to get the current through the resistor, so this is the voltage divided by the, how much? 560,000, right? So I have that much of current going through the resistor and the diode because they are connected in series. So this is the first ID, the current through the diode, right? And if I have the current there, I mean obviously that's the same current as the resistor, right? Plus the VD, everybody knows how to get the VD, right? Because we talk about this many times. Voltage Kirchhoff law, right? So this voltage minus this voltage, that will have the VD, right? You can calculate it. And ID, I show you how we calculate it. So we're gonna increase this to 10. You can take any of these values, just keep flipping, but again I'm not gonna provide you with the table, working table, as you need to get it from the test components here, test devices. That was for 15, then it goes to 20. You can choose any of these values, I mean, you can put like 0.290 here as an example. Let's keep flipping, but here you can get 0.307 as an example for 25 volt, and you do the calculation for the ID and VD, and here you can get like 0.327, 0.329, 0.389. This is the voltage across the resistor, okay? And the rest, here's this is your homework, is doing your Excel sheet and plot these values, okay? I'm gonna stop recording here.